Hey friends, welcome to Nina's Notes 157. The biggest longevity biohack is vaccines. Before we get into it, I need a favor from you. I have a super short 30-second survey that I'm going to link in the show notes. It would be a big favor to me if you could just fill that out so I can know more about you, my listeners, my subscribers, and so that I can create better content. Thank you so much. One of the reasons I started this newsletter was during the pandemic, I would get a lot of calls from my friends and family asking me health-related questions like, what is COVID? How does an mRNA vaccine work? And then I would explain the science to them, and then they told me I should explain it in this way to more people, which led to the creation of Nina's Notes. I've never covered vaccines in Nina's Notes before, and as the Northern Hemisphere heads into cold and flu season, I had some questions come up about vaccines again. So let's talk about it. The biggest longevity biohack is vaccines. I recently learned something that I need to share with all of you, and it's about the COVID vaccines. As you all remember, when we were in the pandemic, the media and information around vaccines was not always the most clear. For the first time ever, the public was really watching the scientific method unfold in real time. We saw scientists learn, experiment, fail, and repeat until we made discoveries about the virus and we were able to create a vaccine. Now, here is the thing that surprised me. When we think of vaccines, we think of the ones that have eradicated a disease, like the polio vaccine, smallpox, measles, mumps, rubella, the list goes on. So a lot of the public thought that when we developed a COVID vaccine, the goal was eradication. I have to admit, I thought this too, and I can't be alone, so that's why we're talking about it right now. But when the vaccines came out and many of us got vaccinated, we all still got COVID. And then the thought was, okay, the vaccine doesn't work, we failed. But eradication was not the goal here. The goal was to ease the burden on urgent care and hospitals. The goal was to keep people out of hospital beds, and the vaccine did that. The first time I got COVID, my case was super mild, and that's because the vaccine worked. My immune system was prepared to fight the virus, and I felt like I had a mild fever and was ill for just a few days. Of course, mentally, I thought, oh man, I still got COVID even though I got the vaccine. This isn't working. And I was wrong. Eradication was never the goal of the COVID vaccine. The goal was to keep the virus from spreading. Things could have gotten much worse without it. And the COVID vaccine did serve its intended purpose, which was offering strong protection against severe illness, hospitalization, and death. The goal was misunderstood by the public and even misunderstood by scientists like me. And if I got confused with all the information presented by the media, I'm sure people without a background in science felt even more confused and didn't know who to trust. What worries me now is that this has raised a lot of disbelief in the scientific community, and this has also spiraled into a greater rise of the anti-vaccine movement. And so this has led me to the article today. Vaccines are our number one longevity biohack. Vaccines represent the single most impactful medical intervention for extending human lifespan and health span. While biohacking usually focuses on optimization techniques like intermittent fasting, supplements, and cold exposure, vaccination offers an unparalleled return on investment. So far, to date, between the years of 1974 and 2024, we have prevented an estimated of 154 million deaths in those 50 years with vaccines and with really minimal individual effort. Vaccines now protect us from 14 vaccine-preventable diseases, and for every life saved with a vaccine, an average of 66 years of full health life were gained. That is seriously the biggest longevity biohack in history. Talk about a hack. So, how vaccines contribute to life expectancy. The longevity community's goal is to extend human lifespan, also known as extending human life expectancy. And vaccines are one of the most concrete examples we have of inventions that have actually increased human lifespan. In the 20th century, life expectancy increased from 32 years to 80 years in developed countries. And vaccines have made a substantial contribution to this 48-year increase, in addition to sanitation, better nutrition, and antibiotics. Even with these improved living conditions, vaccines have still been described as the medical intervention with the greatest beneficial impact on human health and longevity. Furthermore, due to vaccines, infant deaths have halved since 1974, and children under 10 have a 40% greater chance of living to their next birthday thanks to vaccination. Vaccines also have the best effort to impact ratio on longevity. Most common biohacks require an ongoing commitment. Intermittent fasting is a daily commitment with really minimal impact on longevity so far. Cold and hot exposure requires a daily or a weekly practice, and we're still researching the impact on longevity. And then supplements like resveratrol and NAD are expensive and have mixed evidence and are still to be proven for their human longevity benefits. Vaccines are really a set it and forget it biohack. When it comes to biohacks, vaccines only take a minute of your time as an investment. Of course, you'll need additional boosters, but that is also just minutes out of your life. The financial burden is often nothing, as most vaccines are free or low cost in countries with national vaccine programs. And there is a proven impact with decades of data. Vaccines also help raise the longevity of the community. With herd immunity, we only require 95% of the population to be vaccinated for measles, for example, in order to protect those who cannot get the vaccine. For polio, herd immunity is even stronger, protecting vulnerable populations who cannot be vaccinated with only 80% vaccination requirement of the population. When we have herd immunity, we protect entire communities, including infants too young to get vaccinated, immunocompromised individuals, think about people going through chemotherapy or those with autoimmune disease, and we protect the elderly with weakened immune systems. So let's talk about some modern vaccine science. Some of you may have heard of infection immunity. This means exposure to a wild, live virus. Exposure to a live virus is a high risk. It can lead to severe suffering from the illness, spread the illness to others, and long-term effects and hospitalization. This was technology we used back in the 1700s. This was mostly used for smallpox, where people were deliberately infected with material from smallpox scabs or pustules. And this method still resulted in 1% to 2% death back then. And so you may have heard this term, infection immunity, is better because it's natural. Natural doesn't always mean safer. We have improved technology to improve safety. Vaccines train your immune system without the stress of being exposed to the live virus. It's guided, it's safe, and it's smart. And we have several types of vaccines that scientists have developed over the last 300 years in order to improve safety and to be able to target a wider range of viruses, bacteria, and pathogens. So I'll talk you through the different types of vaccines that we have. One is called live attenuated viruses. When we make live attenuated viruses, what we do is we grow viruses or bacteria in the lab to make them weaker or less dangerous. And this allows us to generate strong and lasting immunity without the safety concerns of being exposed to the wild virus. For these vaccines, scientists only use permanently weakened viruses from the lab. And diseases that use live attenuated viruses in their vaccines are measles, mumps, rubella, MMR, chickenpox, nasal influenza, rotavirus, yellow fever, tuberculosis, and typhoid. Another type of vaccine uses inactive viruses. These are viruses or bacteria that have been killed to make a vaccine. So these are dead viruses or bacteria, and they still create a strong immune response. These vaccines are safer for vulnerable populations like immunocompromised people or the elderly. Diseases that have vaccines from dead viruses or bacteria include inactivated poliovirus, IPV, hepatitis A, rabies virus, and some flu vaccines and pertussis. But the technology gets even better. Scientists have improved vaccine development so much that we don't even need to use the whole bacteria or virus to create a strong immune response from our immune system. We can also make vaccines from just a part of the virus. These are called subunit vaccines. These vaccines use a specific part of the virus or bacteria, such as a purified protein or a protein from the pathogen produced in the lab, to generate an immune response. A subunit vaccine is like giving your whole immune system a wanted poster with a criminal's face rather than bringing it the whole criminal. Your security guards, your immune cells, learn to recognize the bad guy from the image of his face without any risk of having to meet the criminal in real life. When the real threat shows up, your immune system recognizes the face instantly and springs into action to protect you from infection. Subunit vaccines often have fewer side effects because the whole virus or bacteria is not present in the vaccine. These types of vaccines are very useful for viruses like influenza or COVID-19 because these viruses mutate very quickly. It's easier to update a subunit vaccine that contains only part of a virus rather than a vaccine designed for the whole virus when the virus changes. Diseases that have subunit vaccines include the Novavax COVID-19 vaccine, hepatitis B, some influenza vaccines, and HPV, human papillomavirus. We also have conjugate vaccines. These are vaccines where a piece of protein is connected to a polysaccharide, a sugar. Most vaccines produce a robust B cell response and produce antibodies when exposed to the pathogen in the vaccine. Conjugate vaccines help to build a powerful adaptive immune response, which means in addition to getting that B cell response, you're also getting a T cell response. T cells only respond to protein. So by connecting the protein of a virus, bacteria, or other pathogen, it triggers your immune system to produce both B cells and T cells. Conjugate vaccines are most beneficial for bacterial infections. Diseases that have conjugate vaccines for them include Haemophilus influenza type B, HIB, pneumonia, and meningitis. And now let's talk about mRNA vaccines. These are the latest achievement in vaccine development. Early foundational research started in 1961 when it was discovered that mRNA is the messenger molecule carrying genetic instructions. This led to the early hypothesis that if you could deliver mRNA into cells, they could produce any protein that you wanted. And in the 1990s, researchers injected mRNA into mice and proved that mRNA could work as a potential therapeutic in living animals. In 2005, Caitlin Carrico and Drew Weissman discovered that nucleoside-modified mRNA, this is when you specifically replace the uridine with a pseudouridine in mRNA, this dramatically reduced the innate immune response to synthetic mRNA, a key breakthrough that made mRNA vaccines feasible in humans. In 2013, Moderna led the first mRNA vaccine trial against flu virus in animals. Results were promising, but more development was needed for human use. By late 2019, mRNA vaccine development had been studied for 30 years. It had been tested on thousands of people across diseases like rabies, Zika virus, seasonal influenza, and CMV, cytomegalovirus, and they were proven safe. Then we saw in real time why COVID vaccines were developed so quickly. Leveraging decades of prior research, researchers were able to leverage the platform technology to swap in the SARS-CoV-2 spike protein sequence into the vaccine. Fueled with massive funding from Operation Warp Speed and global investment, companies were able to start manufacturing before the vaccine was improved, which means they were taking on a financial risk, but not a safety risk. Large trials were able to run more quickly due to the large number of active cases. And COVID vaccines were given regulatory priority, where reviews were expedited but not given shortcuts. This meant we had the first COVID vaccines within 12 months. So, how do they work? The mRNA carries the instructions to make a specific protein from the pathogen, virus, bacteria, or other pathogen. It is then encapsulated in liquid nanoparticles, basically a suitcase made of fat particles. And then this capsule is delivered into a cell where the mRNA instructs our cells to make the spike protein of the COVID virus. Our bodies recognize that spike protein as foreign and then mount an attack on it with our immune system. So why are mRNA vaccines such a breakthrough? mRNA is very versatile. These vaccines can easily be changed when viruses have variants because all we need to do is sequence the DNA of the new virus, and we can quickly learn the mRNA sequence, which will make the protein that we need to train our immune system to fight against. Scientists can also rapidly adapt mRNA vaccines to other systems, like cancer and other deathly diseases. These are the many types of vaccines, and all have been carefully designed and tested to be optimal for the specific virus, bacteria, or pathogen they are intended to treat. You can read more about the history of vaccines in a link I'll put in the show notes. So here's the simple truth about vaccines. When I look at all the biohacks I've tried over the years, the supplements, the fasting protocols, cold plunges, sleep trackers, none of them come close to the proven impact of vaccines. 154 million lives saved. 66 years of healthy life gained per person. These aren't theoretical benefits or trending wellness claims. This is documented, decades-long evidence of what actually works to extend human lifespan. Yet, here I am in Portugal right now. I'm struggling to get the simple flu and COVID vaccine because I'm under 65, and they're not part of the national vaccine program for my age group. It's frustrating, honestly. We live in a time where people will spend hundreds of euros on longevity supplements with questionable evidence, invest in expensive biohacking devices, and meticulously track every metric of their health. But the single most cost-effective longevity intervention isn't easily accessible to anyone who wants it. I'm actively working to get these vaccines because I understand what the data shows. Vaccine is prevention medicine at its finest. It's not about waiting until I'm in a high-risk category. It's about protecting myself and my community now. The COVID vaccine confusion taught us one important lesson. Clear communication matters. The goal was protection from severe illness and death, and it worked. But that misunderstanding had lasting consequences. It's fueled vaccine hesitancy. It's made people distrust the very interventions that have saved more lives than any other medical advancement in history. So my challenge to the longevity community, if you're serious about extending your lifespan and health span, start with the foundation. Get vaccinated. Check your vaccination status. Get your boosters. Don't wait until you're in a high-risk group. This is the biohack with the strongest evidence, the lowest effort, and the highest return on investment. If you can't easily access vaccines where you live, like me in Portugal dealing with the healthcare system here, advocate for better access. Push for policies that make preventative medicine available to everyone, not just the aging and the elderly. The best longevity intervention isn't expensive. It isn't complicated. It isn't exclusive. It's a vaccine. And after 300 years of scientific advancement, billions of doses administered safely, and 154 million lives saved, we have the proof. Now we just need people to trust the evidence. Do you have any questions? Please drop them in the comments or DM me. I will read them all. The book of the week. This week, I read The Witches of El Paso by Luis Jaramillo. 3 out of 5 stars. It really took me a long time to get into The Witches of El Paso, even though the main character is named Nina, although it's spelled differently. So the story follows Nina, a woman living on the border between the spiritual and the ordinary, both geographically in El Paso and emotionally between her past and present selves. The book weaves together 2 timelines: Nina as a young girl growing up in a deeply religious community, and Nina as an adult grappling with loss, motherhood, and the resurfacing of old powers she doesn't fully understand. I struggled quite a bit with these shifting timelines. I found it hard to follow the transitions, and I'm really not entirely sure why. Something about the writing style made it difficult for me to stay grounded in each timeline. But that said, around 75% through the book, the story finally clicked for me. Only once Nina had had her first real witchy experience in the convent, and then Marta channels her witch energy, and we reached the reunion with Rosa, Nina's daughter, I started to feel more connected with the plot and could follow the rhythm of the storytelling. Overall, The Witches of El Paso is a layered novel that rewards patience, but for me, it never fully cast its spell. Check this out. The Oatmeal's take on AI art. It's a long scroll comic. I will link it in the show notes, and I have to say, I agree with it. That's all for today on Nina's Notes. If you like this newsletter, podcast, and YouTube channel, please hit subscribe to the channel here. Subscribe over at my newsletter, www.ninasnotes.xyz. And if you liked it, click the share button, send it to a friend. I'll see you next week.